looking at a few applications of integration. For us, it's mainly to give us a context in which we can use some of our skills like area between curves. So there's a whole heap of text that you can read here about how engines work and this carnot cycle thing. Okay, the key points for us to know is the maximum energy transfer is calculated from the area enclosed by this pressure volume diagram. So you don't need to know the technical values too much. Okay, and the energy obtained is in joules. So what we're trying to find is use integrals to find the amount of energy transferred in the cycle. They give us the equation of the two curves. The curve AB, so this curve has the equation 1 plus 8e to the minus 13.85v, and the curve CD has the equation 1.45 plus 1144e to the minus 33v, and I know the equation of this line is 5, the equation of this line is 1.5. So essentially I need to find the area enclosed in this shaded region. We're going to do that by splitting it into 3 shapes. So here's shape 1, and this little one here will be shape number 2, and that's shape number 3. And so to calculate my energy obtained, I'm going to have to calculate 3 integrals. So shape 1, I'm going to integrate between this point, which is 0.05, and this point, which is 0.175. My top function is 5, and my bottom function is 1 plus e to the power minus 13.85v. And that's with respect to v, because that's my dependent variable on the bottom. For section 2, so I'm going to add on integral from 0.175 to 2 of the top function, this top function, subtract the bottom function, again with respect to v. Should have brackets around these whole integrands. And then also add on integral from 0.2 to 0.3 of my top function, again 1.45 plus 1144 e to the minus 33v, subtract my bottom function, which is just 1.5. If you're uncertain whether you got the top minus bottom function the right way around, you can put absolute value signs around all of these just to be super cautious. Okay, I also need to just note that my pressure is in pascals times 10 to the power 5, which means once I find my answer, I'll need to apply the scale and multiply by 10 to the power 5. Alright, so from here, I would go ahead and integrate all of these things. I'll end up with 0.36, but I need to multiply it by 10 to the power 5. Okay, to apply the scale, which means 36,000 joules or 36 kilojoules. Okay, so that's the idea, finding the area between those two and applying the scale. Another context for us is in economics, in supply and demand curves. Again, you don't need to know this theory really well. If I have a demand curve, the area between the demand curve and the market price is called the consumer surplus. So this little area here is the consumer surplus. which is essentially money saved by the consumer who would have been prepared to pay more for a product than the market price. And the area between the market price and the supply curve is the producer's surplus. Which is extra money made by the producers who get to sell it for the market price, but would have been prepared to sell it for a price a lot lower than that. So look in the example, we're given demand and supply curves for potatoes. Find the consumer surplus and the producer surplus. These two equations are referring to the two graphs above, which means I know that the market price is exactly in between 90 and 120, which means it's $105. Okay, and I also know that the quantity that are demanded for $105 is 15. So to find the consumer surplus, I'm looking for the shaded area, so between 0 and 15 of the demand curve minus the market price. So consumer surplus will be the integral between 0 and 15 of my demand curve minus my market price. And that's all with respect to the quantity. I need to remember, even though my quantity is 15, I need to recognize that there's a scale here. So once I find that consumer surplus, I'll need to multiply it by the scale of 10 cubed. Okay, so I can do that on my calculator and get about $500,000 saved. Can then do a similar thing using the producer surplus. So I need to integrate between 0 and 15 of the market price, which I know is 105, subtract the supply curve. So I'll do that. Integrating between 0 and 15 of the market price minus the whole supply curve. Okay, dx, and again, is there a scale? Yep, need to multiply by 10 to the power 3. Go ahead and do that in a calculator, about $500,000. So from here, there's a few questions for you to have a go at. There's some on carnot cycles, more on carnot cycles, some supply and demand curves, and some other supply and demand curves. Okay, good luck.